Thinking about what we did in activity 2.1, how can we write m of x? The x plus 3 is still x plus 3 times what?
X minus 1.
Is that what f of x is? X minus 1 here? Yes, no, maybe so? Oh, so there's m of x. Hey, Anthony, I'm multiplying two what kind of factors?
Limit.
Oh, so the product, the dilation is a quadratic, a parabola, right? So we want to recognize that. Two quick notes here. Is this, oh yeah, this linear factor, positive or negative slope?
They both positive.
They're both positive?
Yeah, so it's going to be a positive product.
So it's going to be a positive product, which means the parabola would be concave
Up.
up. Oh yeah, that's what we see there, right? That's exactly what we expected to see. What would be the zeros of this new function?
X equals negative 3 and x equals 1.
Okay, notice those are the zeros of the original two linear functions. Alright, now this is where it's going to get fun. I know that y'all hear me say that and you immediately go, ooh, if Mr. Kenny thinks it's fun, it's not going to be fun. But it is. So, number 2 says dilate m of x
Oh my god.
by a factor of x plus 2. Right? So you can continue this table or you can make a new one. I might make a new one to help me organize things. We've got x, we've got m of x, and now what new thing do we need?
Now we need x plus 2.
X plus 2?
Yeah.
And when I dilate those, what function am I getting? P of x. Alright? I'm going to use the same x values. Yeah, probably use the same x values. Does anyone, actually I'll wait for you to write that table down. You'll have to find some space on there somewhere. Or a new sheet of paper maybe. Okay?
Is that negative?
Okay. Does anyone know any important points for P of x that we might need to pay attention to?
I don't know.
I can think of 3.
Dang.
3 really important points to think about for P of x.
We don't even know P of it.
But I do know that P of x, remember, is x plus 2 dilating m of x. So what 3 points might I be referring to is kind of important here.
Yeah, I don't know where you get 3 from, but I think it's 3.
Okay, so what 2 do you see?
Thing. Oh no.
What 2 do you see?
0 plus 2.
What? No,
One of the m of x is 0.
Negative 4 to positive 1.
Say that one more time.
Negative 4 to positive 1.
Those might be x values that I want to look at, but I'm talking about, I see 3 points that are going to be important for P of x.
The x itself.
Oh. Now, I only have 2 x-intercepts right now. What's the third one I'm referring to?
The
Problem?
is it the other one, another one that crosses through the point?
Hold on one second, what'd you say?
Is it another one that crosses through a point?
Yep, it's another x-intercept.
The ones right there by 10.
Negative 4 0.
Oh, the bottom
Not
one.
negative 4, 0. Let me point this out to you really quickly. Y'all have only found the x-intercepts or zeros for m of x.
I'm looking for it.
It's not graphed yet, you can't see it.
oh.
So 0.
M of x is only part of P of x. What's the other linear factor?
F of X.
X plus 2.
Thank you, Kiwan. Oh yeah, there's an x plus 2 there.
Oh.
Oh! What's the 0 for that x plus 2?
-2.
Not just -2.
X equals -2.
So I could even go ahead and plot that 0. We want to recognize the zeros because again, remember, it's around the zeros that the function changes from positive to negative or negative to positive. Notice with the parabola, it went from positive to negative and then from negative to positive there. Now I've got another change.
Okay.
You cannot forget that the important points to pay attention to are the roots or the x-intercepts, the zeros. So we want to note that immediately. Now I'm still going to use those same points that I did before. Now m of x, I already have all those in the previous table. How am I going to get the x plus 2 values? Add 2 to x.
Yeah.
That's it. And hopefully we notice a pattern. What's happening here?
It's just going low.
It's just adding 1 each time. That's the rate of change. And so how am I going to get p of x?
Multiply by m of x
Times
and
x plus 2. It's just the dilation, it's the product.
Why it sound cold?
Yeah,
No.
20, dude.
Oh, what you looking at?
Are there any of these points that I won't be able to graph?
The big numbers. I
The
don't
big
know numbers.
So I probably won't be able to do 60
Yeah.
or 20 or negative 36. But I could graph the rest of those. In fact, I already have some of those zeros already graphed there. So negative 4, negative 10.
1.
Got those 2 zeros there. Negative 1, negative 4. 0, negative 6. And then 1, 0.
2.
Now that doesn't seem like a lot, but we want to recognize that these are negative values, right? So what's the function doing through here?
It's increasing.
It's increasing. Which means it's going to eventually get into the positives, but for it to get back down to 0, it's got to start to decrease. It's going to decrease, 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 and then it's got to start to
Increasing.
So what is it making?
I don't know perfectly what everything will look like, but I can use that information where it's increasing, and it's going to have to be a quick turnaround. It's going to decrease. It's going to have to be a quick turnaround and increase. You think that graph is perfect? No. Is it close probably?
Yeah.
Yeah. Notice I'm using the points that I have to figure out where it's I'm using the zeros and going around the zeros to figure out where it's increasing, decreasing, and then increasing again.
That's weird.
Sorry you feel this way. Does anyone know what type of function this would be? Because we'll have to pick up tomorrow, but not cubic root, just cubic. Right? We had a quadratic. We dilated it by linear to get a cubic. Please note, this is your homework that will, or your reflection and practice assignment that will be due on Friday. You can get started for sure on the graphic organizer. Okay? I do want to point out, we're connecting dilations by linear factors to zeros. There's an important relationship between your linear factors and your zeros. Think about that. This practice assignment you'll probably have to do after we do class tomorrow.
We didn't get a graphic.
What kind of one?
It's the one that you had before the end of in 39 weeks. It's the same one. It's Unit 2 transformations. That is the same graphic organizer.
Yeah, I'm going anyway. You're not safe, y'all.
Miss Courtney, can you pause the camera, take out the SD card, and plug it up?